Hi everybody, it's Mr. Welker, and we are going to be doing Unit 9, Day 3. First thing I want to say is let's make sure that we have our blue reference sheet out and available to us. Um, so far, there's about, you know, 3 or 4 different formulas that we've talked about. So day 1, we kind of talked about these 3 formulas. So this is Unit 9, Day 1. Yesterday, we talked about um, circles. So this is Unit 9, Day 2. So that's this stuff, circles, and I like circumference equals pi d and area equals pi r squared. I am not a huge fan of 2 pi r for the circumference. This is actually our Pythagorean theorem. That's from Unit 8, right? So all of Unit 8 was on Pythagorean theorem. And the rest of our unit is going to be working with these three-dimensional um, formulas. So finding the volume of a prism, finding the volume of a cylinder, a cone, and a sphere. So today we're going to talk about finding the volume of a prism. So let's kind of talk about that uh, today. So Unit 9, Day 3. So you should have these notes out in front of you so that we can go through them relatively quickly. So a prism are any three-dimensional solid that have parallel polygonal bases that are identical, and all other surfaces known as lateral are polygons. Or I'm sorry, parallelograms, right? So the most common prism is a right rectangular prism. And I just think of this as a box, right? So a box of cereal, a box of candy, a shoebox, all of those are basically right rectangular prisms. So we want to find the volume of this prism. So a right rectangular prism is shown below. Answer the following question. What is the volume of this prism? So if we look at this prism, to find the volume, we could use the formula, which is right here, which says the volume of a prism is B times H. So we got to talk a little bit about what that big B stands for. So we're going to use the volume formula V equals BH. And what we really need to talk about is what big B stands for. Big B actually stands for the area of the bottom of the prism, right? Or the base of the prism. So I need to find the area of the bottom of this box, right? So I'm going to draw some dotted lines in here so that we can kind of visualize this as all the different faces, right? So I want to find big B. And to me, big B is always the bottom of my box, right? Well, in this case, the bottom of my box is a rectangle, right? So I kind of find big B first. Big B is a rectangle. And my rectangle, the formula for my rectangle is little base times height, which in this case would be 12 times 8, which is 96. So I know that the area of the bottom of my box is 96 inches squared, right? So now what do I need to do is I need to find the volume. And the volume is just taking whatever the area of the bottom was and multiplying it by the height. In this case, our height is 5. So it's like we're stacking 5 of those bottoms on top of each other, and each one is 96. So 96, stack another one on is another 96, stack another one on is another 96. So this ends up being 96 times 5, and 96 times 5 gives me 480. So our volume here is 480 inches cubed. some of you might be like, we've done this in the past, and the formula we used was volume equals length times width times height. And that's true. That is a very, very good volume formula, but it only works if the bottom of your prism is a rectangle, and not every prism has a rectangular bottom. So we're going to stick with, to find the volume, we do B times H, big B times H. And again, big B just means we find the area of the bottom of our prism, and then we multiply it by the height, like how many of those are stacked on top of each other to create that three-dimensional figure. So B says, how many faces does this prism have? And what kind of shapes are these? And the answer to that is there are 6 faces in this prism, right? We have top and bottom. We have left and right. And then we have the front and the back. And the good news is that in this right rectangular prism, the top and the bottom are the exact same rectangle. The front and the back are the exact same rectangle, and the left and the right are the exact same rectangle. So what they want us to do now is they would like us to find each of the distinct faces. So I'm going to say top and bottom first. So I'm going to draw what the top and the bottom look like as a two-dimensional surface, right? So the top and bottom is just a rectangle where I have 12 by 8. So 12 inches by 8 inches. And then I'm going to draw the front and back, which are exactly the same. So the front and back is also a rectangle, and this rectangle is 12 by 5. And then last but not least, we have the left and right of this right rectangular prism, and that is also a rectangle, and this rectangle is 8 by 5. And what we need to realize is that, again, there's 2 of these, 2 of these, and 2 of these, right? So to find, if I want to try to find the surface area means all the faces added together. So like we're wrapping the box with paper. Like it's a Christmas present or a birthday present, and we got to figure out how much wrapping paper to put on it. Volume is actually filling that present with whatever you want to put in the box. A new outfit, a new game, whatever the box contains, right? So surface area, we're going to find the area of each individual face and then add them together. So it's 12 times 8, because that's the bottom, times 2, because there's a top that matches it. So that ends up being 2 times 96, which is 192. And then I'm going to do front and back. Front and back are both 5 by 12. That's my base and my height. So that's 60. 2 times 60 is 120. And then last but not least, I have the left and right sides. And that's the area of each one would be 5 times 8. So that's 40. 2 times 40 is 80. So now the entire surface area is adding all of these together. So I've got to add 120 and 80. That gives me 200. Throw in 192 on top of that. We end up with 392 inches squared. So lots of little things there, right? If I'm going to find the volume of an object, I'm finding how much space I have to fit on the inside. It's putting the present inside the box, right? If they ask me to find surface area, they're asking me to wrap that Christmas present or that birthday present, and we're trying to figure out how much wrapping paper I'm going to need, right? So there's 2 different questions there. Volume, filling surface area wrapping. So volume of a right prism is given by V equals BH, where B is the area of the base and H is the height of the prism. In the case of a rectangular prism, this becomes length times width times height. But not every prism is a right rectangular prism. So we just got to be careful with that, right? The surface area, on the other hand, again, is covering or wrapping the box, and we have to come up with the area of each individual face and then add them together. So again, we're going to do this one more time. Volume, I think we're filling the present, or filling the box, right? And then surface area, we are wrapping the box. Or, yeah, wrapping the box. So what's inside is my volume. What's on the outside is the surface area. So let's take a look at another example, right? So in exercise 2, we have a right triangular prism is shown below. Its base is a right triangle whose legs are 3 and 4 centimeters in length. The height of the prism is 8. So what we need to do is it says, what is the area of the base of the prism? So they already kind of told us that the base is the right triangle. So this right triangle is my base. And if I draw it over here, my right triangle looks like this. It's 3 by 4, right? And to find the area of a triangle, we know just by looking at our reference sheet, go back over here. If I can't remember, there's my triangle. I'm using this formula right here. So I'm going to go back and I'm going to find the area of, I'm sorry, that wasn't what I wanted to do. I want to find the area of my triangle. So A equals half base times height, right? Or A equals 1/2 of 3 times 4. So that's half of 12, which means the area is 6. So the area of the triangle is 6 centimeters squared. So now if I want to find the volume of this object, volume is big B times H. Good news is we already found the area, or the big B in this case. It is my 6 centimeters squared. So now what do I need to do is I need to find the height, or how far it is between the bottom base and the top base. So my height in this case ends up being that 8 centimeters. So I'm going to put those two into my formula. The area of the base was 6. The height is 8, which means my volume is 48 centimeters cubed. Again, this is a 3-dimensional object. So how much I can fit inside that 3-dimensional object always is cubed. So C says, how many faces does this solid have? Well, this face ends up having, this prism has 5 faces. 5 faces, right? They have a top and bottom that match, right? And then there are 3 rectangular sides. So plus 3 rectangular sides. So those are my 5 total faces. How can we find the missing width of the front of the front face? So basically what they're saying here is, I know enough about the right triangle, right, to find the missing side. I don't know this side of my right triangle, and I'd like to find it. So I'm going to let you think about that for a second. They're saying, I know the 3, I know the 4. Can I find the length of that third side? And I think some of you have probably already came up with it. It's a right triangle. So we could use Pythagorean theorem, or A squared plus B squared equals C squared. Some of you might be thinking, you know what? Based on what I remember from last unit, if the legs are 3 and 4, this must be a 3, 4, 5 right triangle. It's one of those Pythagorean triples. So I know that that third side of the right triangle has to be 5. It was the hypotenuse is a 3, 4, 5 right triangle. So last but not least, they want us to draw each face below and come up with the total surface area. So top and bottom are both right triangles that are 3, 4, and 5, but the area of this would be half base times height, or half of 3 times 4. Oh, I think we already did this one. That ended up being 12, so I ended up with 6. But remember, this is both the top and bottom, so there's 2 of those. So over here, I'm going to write, all right, 6 plus 6. Those are the first 2 faces of our triangular prism, right? Now I'm going to look and I'm going to come up with each of the rectangular sides. So one of the rectangular sides had a height of 8 and a base of 3. So the area of that would just be base times height, or 3 times 8, which is 24. So I'm going to add another 24 here. The next one was 4 by 8. Area of that would be, again, base times height, because there's another rectangle. 4 times 8 is 32. So now I need to add a 32 to that. And I have one more left. Well, I had a height of 3, a height of 8 and a base of 3, a height of 8 and a base of 4. So the last one must be the one that touches the side that is 5, right? So this is going to be my last one. Got another rectangle that has a height of 8, but now the base is 5. So I'm going to do area equals base times height, or 5 times 8, which is 40. So I add all of these together and I'll get my surface area. So the surface area is 6 plus 6 plus 24, that's 12, so 36. 36 plus 32 gives me 68, and 68 plus 40 is 108. And again, the units here, I believe, were centimeters. And because this is still an area, it's centimeters squared. So again, surface area, that's how much wrapping paper I would need to wrap this prism, right? And then volume is how much space I have to fill the object. So the volume ended up being 48 centimeters cubed, and my surface area ended up being 108 centimeters squared, right? So number 3 has another triangular prism. And it kind of walks you through, and we want to come up with the area of the base, and then we want to find the volume of the prism. So there's a little catch to this, so I'm going to let you kind of pause the video and see if you can come up with what the catch is, but it gives you a little hint in A. So read really carefully and pause the video and give it a shot. All right, so basically to find the volume of this figure, I need to be able to come up with the area of my base. And in this case, my base are the front and back, because those are the only 2 that I know are exactly the same. Like the bases have to be the same size and congruent to each other, right? So it's a triangle, and in a triangle, to find the area, we have to do 1/2 base times height, right? But I don't know the height. I know the base. The base is 4. What I don't know yet is the height. So they said, is there a way of using the Pythagorean theorem to figure this out? And the answer is absolutely. And some of you may have already figured this out. If I'm going to try to find that height, I have to think of this as a right triangle. In this right triangle, I have a base of 2, a hypotenuse of 4, and I'm trying to find the other leg. So I'm going to do 2 squared plus I don't know squared equals 4 squared. So this is 4 plus x squared equals 16. We're going to subtract 4 from both sides. They're going to cancel. We end up with x squared equals 12. And as we did before, to get rid of the squared, we're going to take the square root, and x ends up being, and I got to take out my calculator for this. Let's see here. I want to take the square root of 12. And the answer is, and they said round to the nearest hundredth, so I'm going to write a few decimal places here. 3.4641 hundredth means I want 2 decimal places, so I got to look at that 4. And the 4 is not more than half, so I'm going to say that the height is 3.46, which I can then substitute down in here to find the area of my base, right? So I want to find the area of this guy, which is also the area of this guy. So I'm going to type that into my calculator. I'm going to do half of 4, or we could just say that's 2, right? 2 times 3.46, and we get that our area is 6.92 inches squared. That's the area of the triangle. So the volume of the prism, going back, volume equals big B times H. Well, in this case, the big B was our triangle. We found it to have an area of 6.92. The distance between the front base and the back base, or my height, is that 10. So I multiply by 10. Even better, when you multiply by 10, it just moves the decimal place over 1. So I end up with 69.2 inches cubed. So again, to find volume, the key is we must find the area of the base, and then we just multiply the area of the base by the height, or the distance between the top and the bottom base, or the front and the back base. Usually there's a nice hint in there because they'll call it a triangular prism or a rectangular prism. I think those are the 2 most common examples that you're going to see this year. But there are other ones. You could have a trapezoidal prism, but I think that gets a little more complicated than we need to get into. So I would assume triangular bases and rectangular bases are about as complicated as it's going to get for right now. All right. So what I'm going to have you do is stop the video. Tomorrow when you go to class, you can start by working on the in-class practice. And then once that's done, you can work on the delta math that goes along with it. So hopefully that video wasn't too bad. And I hope things are going well. And I will probably have a lot to tell you about this trial when I get back to school. So have a great day, guys, and hope to see you soon.